So postulate is a statement that is accepted as true. A theorem, which is similar to the word theory that you hear in science, it means almost the same thing. It's a statement that has been proven. Okay, so now we're going to outline the postulates for this lesson. Some of these will be common sense, some of them might not be. I'll just write them down, and again, just go with it. If it makes sense to you, great. If it doesn't, I'll continue explaining with pictures in a second. Through any 2 points, there is exactly one line. Through any 2 points, there is exactly one line. So if you have 2 points, and here's your picture, if you have 2 points, there is exactly one line that goes through those 2 points. Pen's not working. That's supposed to be a line. Then the next one is through any 3 non-collinear points, there's exactly one plane. Through any 3 non-collinear points, so what that means is if you have 3 non-collinear points, meaning they're not in a straight line, falls on one plane. So number 3, a line contains at least 2 points. So what that means is if you have a line, then there's at least 2 points on that line, maybe more. And number 4, a plane contains at least 3 non-collinear points. A plane contains at least 3 So if you have a plane, you have at least 3 non-collinear points on that plane. So these two and these two are kind of like forwards and backwards. If you have 2 points, you have a line. If you have a line, then you have 2 points. If you have 3 non-collinear points, you have a plane. If you have a plane, then you have 3 non-collinear points. It's just forwards and backwards. Then, number 5, if two points lie in a plane, then the entire line containing those points lies in that plane. And I'll draw a picture if the words don't make sense to you. If 2 points lie in a plane, then the entire line containing those points lie in that plane. Which, again, it's just explaining something that really makes sense. If you have a plane with 2 points in it, then the line that would go through those 2 points is on the plane. That makes sense. Next one, if 2 lines intersect, then their intersection is at exactly 1 point. So if 2 lines intersect, then their intersection is exactly 1 point. So if you have a line here and then a line that intersects it, the intersection is exactly 1 point. Hi. And the last postulate is, if 2 planes intersect, then their intersection is a line. If 2 planes intersect, and I'll be able to show you a better visual of this on the workbook pages, but for now, if you have a plane and another plane intersecting, their intersection would be at a line. And it'll show better on the workbook pages. Then the last part of this lesson is one theorem, the midpoint theorem. We've touched on this concept a couple times before. Now we're just giving it a name. I'm going to draw the picture first. So what this means is if you have a line segment, let's say this is segment AB, and then you're told that you have a midpoint on that line segment, point M. You're told that point M is a midpoint. That means that segment AM is congruent to segment MB, and this distance equals this distance here. So to put that in words, if M is the midpoint of segment AB, then AM is congruent to MB. That's it. But before we go or move on to the workbook, I just thought of something. While you're here on this page, write your name in pen on the top. So write your name. So that way when you submit your notes, it's already there. Name in pen here.
Can you go back now?
Yeah.